distribution in the last class, and we have done only one problem. So I think you have the normal distribution table with you. So you should keep it with you. Now we can consider, you know that the normal density function, what is the form of normal density function? And in order to use the normal distribution table, we need to convert the given problem in terms of standard normal variate. Okay, Z. Usually the problem is given in terms of uh, general normal distribution with the random variable capital X, but ultimately we have to convert this into standard normal variate Z, where the relation between Z and X is Z is equal to X minus mu by sigma. That is known to us. So before using the table, normal distribution table, we have to convert the random normal variable into its standard normal form. And another point regarding the normal distribution table is that, as you know, that always the areas or the probabilities which are given, that is given to the left of the ordinate. Okay, whatever ordinate you are considering, the area specify the area to the left of that particular ordinate. Remember this. Now, this is one problem. Given a normal distribution with mean mu is equal to 50 and standard deviation sigma is equal to 10, you have to find the probability that capital X assumes a value between 45 and 62. What will be the corresponding probability so that capital X will lie in between 45 and 62? So our problem is to determine the probability, this one, probability that 45 is less than X is less than 62, because X lies in between these two values. This probability we have to find. Now, if you consider this 45 as X1 and 62 as X2, then corresponding to X is equal to X1, I can find what will be the standard normal variate, because the relation between those two variables Z and X is X minus mu by sigma. So when your X is equal to 45, then you can find, I'm denoting X is equal to X1 is equal to 45. Then you can find what is your Z1, because your mean is 50 and standard deviation is 10. These are known. Then for X is equal to 45, X is equal to X1 is equal to 45, your Z value, which is denoted by Z1, that will be equal to X1 minus mu by sigma. And X1 is 45, mu is 50, sigma is 10. So we have obtained minus 0.5. Whereas when X is equal to 62, say X is equal to X2 is equal to 62, your Z value, Z is equal to Z2, say, that will be equal to X2 minus mu by sigma. So you have found Z2 is equal to 1.2. So in terms of Z variable, your required probability will be this one. Originally, in terms of X, you need to find probability that X lies in between 45 and 62. In the last class, I have shown that area under this random normal variable X is equivalent to the area under the corresponding standard normal variate. So this probability that X lies in between 45 and 62 will be same to the probability that Z lies in between minus 0.5 and plus 1.2. Why we have transformed? Because we can use the normal distribution table instead of calculating. So this means it is the area, which area? Which is bounded by these two standard normal variate, minus 0.5, Z is equal to minus 0.5 and Z is equal to 1.2. So in the figure in 9, you can find the area, say Z is equal to minus 0.5 and Z is equal to 1.2. So corresponding to this, we have to find what will be the area in this case. So area to the left of Z is equal to 1.2 minus area to the left of Z is equal to minus 0.5. In your random distribution table, you can find what will be the values. Just check your normal distribution table. What is the area to the left of Z is equal to 1.2? Can you tell me what is the area?
0.884939.
0.8849.
49, yes.
And area to the left of Z is equal to minus 0.5.
0.308.
0.3085. Anyway, so this is the area. So their difference will give you the required area, which is lying in between Z is equal to minus 0.5 to plus 1.2. The shaded region is the required probability. Okay. So this is how we are finding the probability. And this result will be the result corresponding to your X variable. So this is how we are using the normal distribution table. In the last class, I think this problem is clear to you.
Ma'am, in the uppermost column, just beside the x, some values were given 0.00.01.
Yes.
What are these
So
values?
if your Z value is not only in the first decimal place, if it is in the second decimal place also, then you can use the horizontal row value. Understand? Suppose you want to find Z is equal to 1.28. So 1.2 is given on the left vertical column. Plus 1.2 is given on the left vertical column. How can you find the second decimal place? 1.28, suppose Z is equal to. Then that 8.08. So you can find that on the topmost horizontal column. Is it?
Yes, ma'am. And ma'am, all the transformed curve will superimpose normal distribution curves that are transformed.
What is that? What is your question? Not clear.
My question is that any kind of normal distribution curve, we are transforming it in the form of z.
Huh? What is
So
the form?
after transform in the form of z,
Yeah.
will all the transformed curve superimpose with one another?
Will all transform curve what?
Superimpose.
Actually, for this Z transformation, in the transformed variable Z, you know that the mean is always 0 and the standard deviation is always 1. That also I have shown in the last class. Have you remembered that?
Yes.
So the
Yes,
pattern
ma'am.
of
Yes,
the
ma'am.
curve will be always same.
All right, ma'am. Thank you.
Okay. It is fixed. Mean and standard deviation in terms of standard normal variate is always same, 0 and 1 respectively. Okay. Now, let us consider another problem. Till now, we have considered two problems, and there you have found that you need to find the probability, or in other words, we can say we need to find the area to the left of the ordinate. Okay. And the ordinates are specified. You need to find the area. But on the other hand, if you want to consider the reverse case, that means if you want to find what will be the ordinate if the area is given, then that can also be determined by considering your normal distribution table. Here is one problem. Let us consider this one. Problem number 3. Given a normal distribution with mean mu is equal to 40 and standard deviation sigma is equal to 6. Remember that this mean and standard deviations are corresponding to your normal random variable capital X. Now find the value of X. Find the value of X that has 45% of the area to the left. So this area is specified. 45% means 0.45. Area is 0.45. Then you have to find what will be the value of X for which the area to the left of the ordinate will be 0.45. Now, whenever this area is given, you have to find the X value, ordinate in terms of X. But in the normal distribution table, the area is given in terms of Z value. Remember that, not in X. So whatever Z, whatever ordinate you will get from that normal distribution table, that will be in terms of Z. And then from that Z value, from the transformation Z is equal to X minus mu by sigma, you have to find what will be the corresponding X value because mu sigma are given. Am I clear?
Yes, ma'am.
Or shall I repeat? I'm repeating once again. Your area is given and you have to find the x value. X value means for which ordinate of x for which the area is 45%. But 45% means 0.45. This area in the table is given in terms of Z. So 0.45 is in terms of Z, and that area will give you some Z value for which ordinate of Z you are getting the area to the left of that Z value as 0.45. So you can find what is the Z value from your normal distribution table. And
Ma'am,
after that, yes,
Ma'am, in that question, mu and sigma will be also given.
mu and sigma, these are, yes, mu and sigma for Z value is always 0 and 1. As I have mentioned, for standard normal variate, your mean is always 0, standard deviation is always 1. Am I clear?
Yes, ma'am.
Have you understood that?
Yes, ma'am.
Okay. So whatever area is given, remember that this area is only in terms of Z, not in terms of X. But ultimately you have to find the value of X. So first you find in terms of Z, and then you know the conversion Z is equal to X minus mu by sigma, where that mu is the mean of corresponding to X variable. This is a standard deviation corresponding to X variable, because for Z variable mean is always 0 and standard deviation is always 1. So once you have determined the ordinate from your normal distribution table corresponding to the area 0.45, then you use that conversion, you will find the value of X. Now, 45% area, suppose corresponding to Z is equal to some value, say Z1. We don't know what is Z1. Say for Z is equal to Z1, area to the left of that Z1 value is 45%. That means 0.45. So I can say if Z1 is the required standard normal variate for which the area to the left of that Z value is 0.45, that Z value, Z is equal to Z1, probability that Z less than Z1, less than or equal to Z1, that will be equal to 0.45. But we don't know what is Z1. We know what is the area 0.45. So look at your normal distribution table, and there from the probability or from the area, can you find any value which is exactly 0.4500 or very close to 0.4500? It is not always possible to get all the exact values. You may get some value which is very close to that 0.45. Can you find any value?
Yes, ma'am.
Acha.
Minus
What
1.
is that
0.
value you
0.1.
have?
Minus 1.7. That is 0.446.
Minus 1.7.
7.
Is it? Is it?
It is
Minus
0.4.
No, ma'am. Minus 0.12, ma'am.
Minus 0.12.
We get 0.4522, ma'am.
You are telling different values. Why? Only
Ma'am, he
you
was telling for 0.045, ma'am.
0.045.
Yes, ma'am, the before person. I was telling for
Achha,
0.
just take corresponding to 0.045. What is the area? You won't get 0.045 that area. Look at that. No. That is your 0.6736. But you need to find the area 0.45, nearly 0.45.
Minus 0.12, ma'am, that is.
Minus 0.12 or maybe 13. Yes, correct, that one. Look at that.
Yes. Ma'am, for minus 0.12, it is 0.4522. But for minus 0.13, it is 448.
Yes,
Okay,
yes,
okay, yeah, it is
0.4483. So we can take 0.4483. Other students, can you identify the area 0.45? Exactly 0.45 is not available. You can get 0.4522, or you can get 0.4483, but 0.4483 is much more closer to 0.5 than 0.4522. Have you found that?
Yes, ma'am.
In your supplied table, the very first table, A3 table, in the A3 table A.3, there in the last but one row, in the last but one row, you can find in the third column and in the fourth column, last but one row, third and fourth column. In the third column, the area is 0.4522. In the fourth column, it is 0.4483. Which one is closer to 0.5? 0.45.
483.
So 0.4483. And this 0.4483, it is lying at the intersection of which Z value? Minus 0.1 and on the top 0.03. That means the value of the Z is minus 0.13. Okay. So here your Z1 value will be minus 0.13, and that's why I have written here, which is found to be minus 0.13 from your normal distribution table. So once you have determined the Z value, now it is possible to find what will be the corresponding X value. So because your transformation is like this, so X will be equal to mu plus sigma Z, where mu and sigma, these are given 40 and 6 respectively, and Z value is minus 0.13. So your X value, corresponding X value will be 39.22. Is that clear? Have you understood this?
Ma'am, from where are you getting 0.45?
No. In the question, it is given that that has 45% of the area to the left. 45% means 0.45.
Okay, ma'am.
Out of 100, it is 45. That means 0.45. We are getting the area which is given in the question. Mu, sigma, and area is given. In other problems, you have seen that mu, sigma, and the ordinates are given. But here you have to find the ordinate. Area is given. Okay. And from that area, we have found what is the Z value. Is it okay now?
Yes, ma'am.
So that means normal distribution table can be used for both the purposes, in order to find the ordinate or in order to find the area as well. Now, one more point I should mention. Suppose you are given, suppose here in this case, the area is 45%. Suppose you are given some area which lies exactly in between two tabular values. In this case, your 0.45 is close to 0.4483. But if the value, if this area is given such that this area lies in between exactly two consecutive tabular values, then how can we find the corresponding ordinate? In that case, since it is at the middle of that, so you just find the previous area for which you have to find the Z value, and you have to find the successive area for which you have to find the Z value, and then take the average of those two Z values. Because your given area is exactly in between two successive tabular values. So you have to take the corresponding Z values for those two areas from which your given area is equidistance, and corresponding to those two areas, find the Z values. You will get two Z values, and then take the average of those two Z values. That will give you the Z value corresponding to your given area. This point should be noted. Otherwise, if your given area is leaning towards a specific value of the table, then you have to consider that Z value, as you have done in this case. Have you understood that?
Yes, ma'am.
Okay, now let us consider another problem. Here it is. A certain machine makes electrical resistors.
Ma'am, can't see the problem.
Yes, ma'am. The
Can't see
problem
the
2 is
problem.
visible only.
Only the problem 2 is visible on the screen.
Can you see the problem? Problem number 4?
No,
No,
ma'am.
No, ma'am.
No.
We couldn't even see problem number 3 also.
The
Ellipse number
page
2
is
is
actually just
You
stuck on
couldn't
the
see problem number 3 also.
Yeah,
No,
ma'am.
ma'am.
No, ma'am.
Just a
Yes,
minute.
ma'am. We
Then you
can't
should
see
tell me.
problem number 3.
Okay. Once again, I am uploading that. 1 minute. Now, can you see problem number 3?
Yes, ma'am. Yes.
Yes, ma'am.
Ma'am.
Okay, so this was the problem which I have solved. Given a normal distribution with mean mu is equal to 40, standard deviation is equal to 6, you have to find the value of x that has 45% of the area to the left. That I have solved, this one.
Yes, ma'am. It is clear.
Okay, is it all right now?
Yes, ma'am.
Okay, now
Yes.
let us consider the next one. Problem number 4. Is it visible now? Problem number 4.
Yes, ma'am.
Yes, ma'am.
Fine. A certain machine makes electrical resistors having a mean resistance of 40 ohms and a standard deviation of 2 ohms. Assuming that the resistance follows a normal distribution and can be measured to any degree of accuracy, what percentage of resistors will have a resistance exceeding 43 ohms, given that area to the left of Z is equal to 1.5. Area to the left of Z is equal to 1.5 is 0.9332. So you need not require to see the table, the value is given, some value is given. What is the question? Some person is making some electrical resistors which has a mean resistance of 40 ohms and standard deviation 2 ohms. Okay. Now, assuming that the resistance follows a normal distribution and can be measured to any degree of accuracy, what percentage of resistors will have a resistance exceeding 43 ohms? Now, in this case, can you tell me what is given and what you have to find?
Ma'am,
we are
we have been
X, ma'am.
x1. X1 is given. We have to find the
X1. What is your X1? Right, absolutely. What is your X1?
43.
43, absolutely. And you have to find the corresponding area or probability.
Yes,
So which probability you have to find if capital X represent the random variable, the resistance of the resistor. So you have to mention what is your capital X. Suppose X is
greater than 43.
Yes, ma'am.
So what you have to find, what percentage of resistor will have a resistance exceeding 43? Absolutely. So you
Yes,
have to
ma'am.
find probability that X will be greater than 43. Okay. So your X1 is 43. You can transform this in terms of Z1, Z value, because always the tabular values are given in terms of Z, as you know. So we have done that. You have to, X is the resistance of the resistor. Here X is equal to 43. You have to find X to be, and this X should be capital X, random variable. Probability that X will be greater than 43, that we have to find. And when X is equal to 43, what will be your Z value? That can be determined. So we have determined Z will be equal to 1.5. When X is equal to 43, your mu is 40, sigma is 2, Z is equal to 1.5. So probability that X is greater than 43 is same as probability that Z is greater than 1.5. And that can be denoted because always area is given to the left of the ordinate. So that's why I have transformed this as 1 minus probability that Z less than equal to 1.5. And this area to the left of Z is equal to 1.5 is given as 0.9332. So 1 minus 0.9332 will give you the required area. But remember that the question is what percentage of resistors? So don't stop here. You have to find in terms of percentage. So you have to multiply this one by 100. So 6.68% of the resistors will have a resistance which exceeds 43 ohms. This will be the answer. Okay.
Okay, ma'am.
Yes, ma'am.
Good. Alternatively means we have done in that manner. Okay.
గనవాడు చేస్తున్నాడు ఫోన్
Yes, once again.
ఓ 2 నిమిషాలు ఎత్తాను
Huh? Anyone is
His-
telling anything?
His microphone
him?
was unmuted mistakenly.
Am I audible?
Yes, ma'am. Yes, ma'am.
Yes. Yes,
Okay.
ma'am.
Yes.
Now somebody is telling, I have to unmute. It is already unmuted. Anyway, this is another problem. I think this you can do yourself. Okay. Problem number 5. That is almost similar to the previous problem, so you can do yourself also. And in the question, you must be very careful whether it is given that you need to find the answer in the percentage or not. If it is mentioned in the percentage, always find in percentage. Just multiply this probability by 100, that will give you the percentage. You can also do this one. This is also a little bit similar. Let us first do the problem number 7. In an aptitude test administered to 900 college students, the mean is 50 and the standard deviation is 20. Then you have to find, there are 3 parts. First part, the number of students securing between 30 and 70. Marks is 30 and 70. You have to find the number of students who obtain the marks between 30 and 70. This is the first part. Part 2 is you have to find the number of students who exceed 65. And the third part is you have to find the value of the score which is exceeded by top 90 students. These are the 3 parts. So let us first consider the first part. 900 college students are giving their exams, and in their test, the average is 50 and standard deviation is 20. Then, first of all, you have to find the number of students who is scoring in between 30 and 70. So in this first part, how will you proceed? What are the given information? Let me know what are the given information. As you have seen, we are, the marks is given between 30 and 70. So they can be chosen as x1 and x2. 2 values of x are given. Lower value is 30, upper value is 70. What else are given?
Mean and standard
Mean
deviation.
and standard deviation. Okay. Mu is equal to 50 and sigma is equal to 20. Correct. And anything else? What is this one? 900.
The range of,
yes.
the range of x is given between 30 and 70.
Yes. Say x1 is equal to, as I have mentioned, x1 is equal to 30 and x2 is equal to 70. That is given. Mean standard deviation, that is also given. And another quantity is given, 900. Total 900 college students are there. Remember that. So out of that 900 college students, how many will get the marks between 30 and 70? That you have to find. Okay. So that is not very difficult. When x is equal to x1 is equal to 30, you can find what is z1. And when x is equal to x2 is equal to 70, you can find z2. If capital X represent the number of students securing the marks between 30 and 70, then you have to find the probability that capital X will lie in between 30 and 70. That probability you have to find. Okay. So for x is equal to x1 is equal to 30, we have obtained z1 is equal to -1, and for x is equal to x2 is equal to 70. Z2 is obtained as 1. So probability that X1, capital X lies in between X1 and X2. Your X1, X2 means 30 and 70. So probability that X lies between 30 and 70 is same as the probability that Z lies in between -1 and +1. Okay. So you have to find the area in between Z is equal to -1 to Z is equal to +1. So how will you write this probability? Probability that -1 is less than Z is less than +1. That will be equal to what? Area to the
Ma'am,
left.
probability of
Yes,
Z less than 1
right.
minus probability of Z less than or equal to -1.
-1. Okay, good. So in that way, you can find that probability. So probability that Z less than -1 and it will be less than equal to, though the value will remain unchanged, minus probability that Z less than equal to -1. Okay. And you can find from the normal distribution table, you just find what will be the value of that when Z is Z less than +1. What will be the corresponding value in terms of normal distribution?
0.8413.
Point.
8413, ma'am.
And for -1?
0.1587.
8413.1587. So you can find 68.6826. So this is in terms of probability that the number of how many students are lying, whose marks will lie in between 30 and 70. But total, how many total number of students are there? 900 students.
900.
So out of 900, what will be the number that is multiplied by this? So it is 614.34, but number of students cannot be in fraction. So it is approximately equal to 614. Because after decimal, the number is less than 5. So I will take 614. So approximate number of students who has obtained the marks in between 30 and 70 will be 614. And the second part, what is the second part? The second part is you have to find the number of students whose marks exceed 65. That means which probability shall I have to find?
I'm less than
Probability is
65.
greater than 65.
X
Greater than
greater
60.
than 65. Yes.
Yes.
We now have to find probability that X is greater than 65. Okay. And that we have done. X is greater than 65. And for 65, X value 65, what will be the Z value? Z value is obtained as 0.75. So,
Ma'am,
yes, be louder.
when we are saying the total number of students having score between 30 and 70, then 30 and 70 are included or it is excluded?
No. 30 and 70 are the marks and student is X. This is the number of students whose marks lies in between 30 and 70.
That means the 30 and 70, the specific marks are excluded, right?
30 and 7 in between, they have told in between, so you can exclude that one, 30 and 70. That's why we have written not equal to, less than equal to. Yes. What is your question then?
That was question.
That was to include the extreme values or not. That really was the question.
Once again, repeat loudly.
Ma'am, for the value PZ less than 1, we are also including the value of PZ equals to 1.
Because what is your actually in terms of X, you just see 30 is less than X. And corresponding to 30, Z value is -1, corresponding to 70. X is less than 70. So it will be less than 1, corresponding Z value less than 1. In between -1 to +1. Okay. Excluding those two. So if I take Z less than 1, that means you are excluding 1 plus 1. And since you are subtracting this, so -1 should be subtracted because it is not included in this range. In this case, it should be less than equal to -1. Have you understood?
Ma'am, but the thing is, P of Z equals to 1 gives 8.1, 0.8413. P of Z equals to 1 gives this value. So we have to consider
You
some
have
value.
confused because these are your continuous random variables.
Yeah,
So
yes.
Z less than 1 means you are considering the value 1 only. How can I say Z less than 1 means which value will you take?
Yes, ma'am.
Let
Yes,
me
yes.
know. If you consider Z to be less than 1, every time we are doing in that manner. In earlier questions also we have done. If you consider Z to be less than 1, which value shall you take for Z less than 1? Is it 0.9? Whatever value you will tell which is less than 1, I can always take some other value which will be lying in between your value and 1. Always, because it is due to continuity. That means whatever value you are taking less than 1, which is very, very, very close to 1, again you can find another value which will be lying in that value and the value 1. Always it is possible. That means it is ultimately approaching to 1, but very small deviation, which we cannot measure actually. 0.0000, infinite number of 0, then some numerical value. So that means it is almost equal to 1. And in order to find the area, you have to consider some particular value. You cannot say that Z will be less than 1 means some value. So corresponding to 1, we are considering that. How can you state that? When you are doing the numerical results, that will correspond to this value only because these are your continuous random variable. That's why.
Yes, ma'am.
I have understood your point. Because this value will be little bit less than, for probability Z less than 1 should be little bit less than your 0.8413. You want to mean that? No.
Yes, ma'am. Actually.
Okay. But because of the continuity, we cannot measure that one. And at every point, your tabular values will not be given. Infinite number of points are there. Even if you take very small value, which is less than 1, still there will be infinite number of values. So that's why we are always taking in this manner. Okay. Now the second one, probability that Z will be greater than, X will be greater than 65 and corresponding Z value is 0.75. So Z will be greater than 0.75. That means because area is always given to the left, so I have to write this in terms of less than equal to. So 1 minus probability Z is less than equal to 0.75 and that value for Z is equal to 0.75. The value is obtained as 0.7734. So you have obtained the probability and you have to find the number of students. So it should be multiplied by 900 because total number of students is 900 and that gives you nearly 203.94 means it is almost equal to 204. Now the third case. Look at the third part. You have to find the value of the score exceeded by the top 90 students. Is it the same as part 1 and part 2? In the third case?
No, ma'am.
Here we have to find the probability first of top 90
You have to
students.
find the probability also means a little, make it clear.
Ma'am, percentage
The
is
percentage.
given here.
Yes, ma'am.
The
Yes.
percentage,
Your
10% is given
that
here.
means you can say
10%.
that the probability is given almost, isn't it?
Yes, ma'am. Yes,
You
yes.
have to
Yes,
find
ma'am.
what is the score. Find the value of the score exceeded by the top 90 students. So if you take the value of the score as X or in terms of Z, whatever it is, because ultimately we have to find in terms of Z. Okay, so I can consider that value as Z value. Okay, so if I consider in this case that your Z value says Z is equal to Z1. So you need to find the score which will be exceeded by top 90 students. So suppose Z is equal to Z1 is the value and probability that Z will be greater than Z1, that this number will be exceeded by top 90 students. Top 90 students out of how many students? 900 students. So probability that Z greater than Z1 will be equal to 90 by 900. That is 0.1. This first line, is it clear to you?
Yes, ma'am.
We have considered, we don't know what is the score, which will be exceeded by top 90 student of the class. The score is not known to us, but we know that is the score which is exceeded by top 90 student of the class. We are assuming that that score is Z is equal to Z1. Okay. And that should be exceeded by top 90 students. So if Z is the score probability, that score will be more than Z1. That probability is given by what? Top 90 student out of 900. So 90 by 900, the probability that this Z1 score will be exceeded by top 90 student is equal to 90 by 900. Out of 900, 90 student will get the marks which is greater than Z1. Meaning is this one. So probability that Z will be greater than Z1, Z is the score, greater than Z1 will be equal to 90 by 900, which is equal to 0.1. So we need to find this probability. What is the Z1 value for which probability is 0.1? Is this line clear to you?
Yes, ma'am.
Yes.
Okay. Now, always in the table, the area is given to the left. So I can write probability Z greater than Z1 will be equal to 1 minus what?
Z less than equal to
Z
Z1.
less than equals to Z1.
Z1. Absolutely. So it will be 1 minus probability that Z less than equal to Z1, and that is equal to 0.1. So I have taken this probability part on the other side and the numerical part on the another side. So probability that Z less than equal to Z1 will be equal to 1 minus 0.1, that is 0.9. And now you can find, is there any area corresponding to 0.9? Can you find any area which is equal to 0.9 or very close to 0.9?
Ma'am, Z equals
1.997.
0.901.
0.9 you are telling. Let me check also. Point?
Ma'am, Z
Nine.
equals 1.28.
No. What is
Yes,
the
ma'am,
area you are?
Area is 0.8997.
0.8997.
8997. Okay, let me check. 89, yes, 8997. And this correspond to which Z value?
1.28.
1.28. Absolutely.
1.28, ma'am.
Yes,
1.28.
exactly. So 0.9 area is not exactly there in the table, but point, uh, 0.9.
And 1.29 is also closer.
900. Achha, 1 minute, 1 minute. This means 0.9000. So you have told which value? No.
1.28.
No, you are telling 8997.
0.8997.
Yes, 1.28. Right. I have seen the table. So corresponding to that, the Z value is obtained as plus 1.28. And once we have determined the Z value as 1.28, your X value can also be determined because mu and sigma are already given. So X value is 75.6. So this is the score which will be exceeded by top 90 student. Either you can write in whole number, the score can be written in whole number. If it is whole number, then in terms of 76, otherwise 75.6. So this score will be exceeded by top 90 student. Okay. So this is how we are considering the problem. And two other problems are there. You can go through that. These are already given. So I think I can stop here. But one of the student mailed me that he had not understood the derivation of the variance of normal distribution. Others, have you understood what is the derivation of the variance? Have you seen that?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So have you understood that?
Yes, ma'am.
Okay.
Yes.
all of you have understood. One of the student has
Yes,
made to describe that. No, I don't have any problem. Others can leave. Those who have not understood, I can explain that one once again. And others can leave if you want. And if anybody want to know once again, I can explain just now.
Ma'am?
Yes, yes.
Ma'am, as the normal distribution function is
I will share the assignment by this week only. Okay, by this week I will share the assignment on probability. Yes, yes. Tell me.
ma'am, as the normal distribution function is continuous, so we can take the value 0.8997 instead of 0.9, as it is come closer to 0.9.
Yes, yes. Because all the tabular, you cannot get the values for all numerical Z1. All values of Z1 is not possible. It is given 0.07, then 0.08, but there are infinite number of points of Z1 in between 0.07 and 0.08 and everywhere. So they have given some of the values, and that's why we are taking the value which is closer to your given value.
Ma'am, I
Okay,
have a
ma'am.
doubt regarding the transformation, ma'am.
Yes, once again repeat loudly.
I have a doubt regarding this transformation, ma'am. As we are using z equal to x minus mu by sigma, right, ma'am?
Okay.
Yeah, here I mean, z equal to x minus mu by sigma for z, standard normal random variable. For z, mu equal to 0 and sigma equal to 1, right, ma'am?
Standard normal variable has the mean 0 and variance sigma 1.
Yes, ma'am. But when we are using the transformation for these problems, we are considering mu equal to 50. I mean, some value and sigma equal to some value, and we are equating
That
it
is
to
in terms
z
of
number.
x. X value, x random variable can have any mean, any sigma. And
Okay,
that is
ma'am.
finally transformed to z value.
Okay, ma'am.
Right.
Got it, ma'am. Got it, ma'am. For x, it is having the mean and
Different
deviation
mean
value.
and sigma. In terms of x random variable, the distribution can have different. I have shown in the earlier class that you are getting different type of normal distribution curve. This is due to different mu and sigmas, as I have shown in the last class.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
So in terms of
For
x variable, your mu and sigma can be different.
yes, ma'am. Got it, ma'am. For z, it has to be 0 and 1.
For standard normal distribution, that is in terms of z, it will be always 0 and 1.
Okay, ma'am. Got it, ma'am.
Okay.
Thanks, ma'am.
And ma'am, I am having
Yes.
problem in understanding where we should apply the binomial distribution regarding the application.
Yes, yes. So as I had mentioned, the binomial distribution has probably 4 characteristics. Bernoulli process, I have mentioned one Bernoulli process. The 4 characteristics are, first one will be, it will have finite number of trials, n number of trials, say. Secondly, first point should be the experiment will have only 2 outcomes.
Yes, ma'am.
As you are tossing a coin, one head, one tail, isn't it?
Yes,
As
ma'am.
you are
Yes.
tossing a die, either you will get one or you will not get one, isn't it?
Yes.
Other than
Yes.
one.
Yes.
Or when a patient is under treatment, either he will survive or he will not survive. Like that.
Yes.
Only 2
Yes.
outcomes. And in general, we are denoting those outcomes as success and failure. So if in
Yes.
an experiment number 1, there are only 2 outcomes. Number 2, the number of trials will be finite. Number 3, all the trials will be independent of each other. And number 4 is the probability of each trial will remain unchanged. As for example, when you are tossing a coin, the probability of occurrence of head will always remain half. It is not changing in any trial.
Yes.
And similarly, the probability of tail will also not change. So if these 4 characteristics are satisfied, then you can apply the binomial distribution. And in your case, it is quite obvious that if the situation is a discrete case, you have to apply binomial. And if it is a continuous case, you have to apply normal, because you have done only 2 distributions. So it is much more easier to identify. At the moment, it is very easy to identify which particular distribution will you apply. Discrete case,
Okay.
if the discrete random variable, apply binomial. If it is continuous random variable, then you have to apply the normal distribution.
Okay, ma'am. Got it.
Okay.
Thank you.
So do anyone want to know again the derivation of variance for normal distribution? One of the students had mailed me that he want to know the derivation is not very clear. So if it is so, then I can explain that once again now. If you are having time, I can explain. I don't have any problem. And by this week, I will send the assignment on probability. And from the next class, actually, I have completed my probability part. So from the next class, some other topic will start and some other faculty member will take your class. Okay, my part is over. Even then, if you are having any problem, you can mail me. Okay, or you can write in this MS Teams chat box also if you are having any problem. But for the present, I have completed my part on probability. Other topics will be done. Next class will be taken by some other faculty member. Okay. Now you can leave then. If nobody has any question, you can leave now.